Hello everyone. So today we're going to go ahead and continue on simplifying trig expressions to build us up into proving trig proofs. Trig proofs. Alrighty, so let's go ahead and begin by starting off with this question. Sine times secant equals cotangent. Do you agree with this statement or you disagree? So go ahead and give it a try. Use your notes. Okay, and we will meet here in a little bit. Okay, so we have the following question, and the first thing that I want you to do is label everything in terms of sines and cosines. So we can see here from our notes, just like I have here on my side, I'm going to go ahead and see that everything, I'm going to change it to sines and cosines. If it's already a sine, like this case, I'm going to leave it as it is. So it's going to be sine of x times secant, on the other hand, is the reciprocal of cosine. So I'm going to use this one, and this identity tells me that this property is 1 over cosine. So I'm going to go ahead and rewrite it by substituting it as cosine in the denominator. And notice that these are interchangeable because they are equal to each other. And then cotangent, on the other hand, is not going to be, it is true that it is 1 over tangent. That is true. But in terms of simplifying to sines and cosines, I'm going to go ahead and use that cotangent is the same thing as sine cosine over sine. Cosine x divided by sine of x. Okay, from here, what I'm going to go ahead and do is multiply. So I know a lot of us get a little intimidated by when we see these being multiplied together or added together, but I want you to think back on what you learned already about addition and subtraction of numbers. You can go ahead and put this over 1 and you can multiply straight across. Nothing has changed, guys. This is still sine of x times 1 is still sine. 1 times cosine is equal to my right hand side, which is cosine of x divided by sine of x. Okay, so this right here is my solution. This is my left hand side. This is my right hand side. Now I want you to look at this. This equal sign is telling me that they are equal. Is this true? Well, unfortunately, it is false. Um, this is not true. The left hand side does not equal to the right hand side. In this case, we are saying tangent of x is equal to cotangent of x, and that is not true. So we need to make sure we put this little not equal sign. Okay, so let's go ahead and try some more problems. We have a week at a glance. So my students, I told you guys already in class that, hey, the trig flashcards are due, and we will be having power hour at 2:30. So please join me, especially the students that have not turned in assignments. This will be very, very beneficial. Okay, and looking at the week before we go off into Thanksgiving break, we will be continuing on these trig proofs towards the week and solving equations on Friday. Okay, so let's go ahead and begin. Alrighty, we will be continuing to simplify these trig identities. Okay, so from yesterday's notes, we are familiar with these right here. These were from yesterday. The only thing that I am adding today is these right here. So go ahead and take a couple seconds to write this down. We have cofunction identities and even and odd identities. Okay, awesome. Hopefully that was enough terms. If not, pause the video for more time. And let's go ahead and continue. It's not letting me. What the heck? Okay, so we have this right here. We have sine times cosecant minus cosine equals sine squared. So what I want you to do is change everything, guys. Change everything into sines and cosines. Okay, now this won't always work, but does give you a path to some direction that which we will go to. Okay, so if you have no clue, you look at this and you're overwhelmed, change the sines and cosines and let's see where you go from there. So let's go ahead and use different color. Purple sounds great. So in this case, sine is already sine, so I'm going to leave it as it is. Sine of theta times cosecant. Cosecant is the reciprocal of sine, so it's going to be 1 over sine of theta. minus cosine squared theta. It's already a cosine, I'm gonna mess with it, is equal to sine squared theta. We have here sine on the numerator, right? Sine on top and sine in the denominator. So when you multiply this, guys, you have sine of theta divided by sine of theta minus cosine squared theta. Okay, now what I want you to know is the following. This right here is 1 minus cosine squared theta equals the right hand side, which we have here is sine theta. So let's go ahead and check. Is this true? So what I want you to know is that whenever you see something, whenever you see a 1, whenever you see a trig function squared, you should immediately start thinking about the Pythagorean identities. So I'm going to go ahead and ask you, so from these three, A, B, C, and D, from these Pythagorean identities, which one is most likely to have majority of the parts that we have here in our picture, in our solution so far? So hopefully you said A, and in this case, A has the cosine, right? The sign is changed. I'm sorry, the sign is changed, like positive, negative, and 1. Okay, we're not going to go ahead and rely on the right hand side, which is sine squared theta, because we don't know that yet. We wanted to equal that, but as of right now, we're looking at the left hand side. Okay, so it would be to our best interest to use the first equation, which says cosine squared theta plus sine squared theta is equal to 1. Now I'm going to go ahead and manipulate this by subtracting cosines, because this cosine is negative, and the only way I can make it a negative is if I subtract it on both sides. So we have sine squared theta is equal to 1 minus cosine squared theta. Okay, so this is what I want you to know. I want you to see that, hey, this right here, I don't know why my pen's not working again. This right here, sine is equal to this right here, 1 minus cosine. And look, we have that right here, 1 minus cosine. So therefore, I can go ahead and swap what it equals to, right? Because it's equal to this, and it's also equal to this. And we can see that, hey, sine squared theta is equal to sine squared theta. So indeed, this is true. The left-hand side is equal to the right-hand side. Okay, awesome. Let's continue with another example. So go ahead and pause the video and give it a try. We have cosine times tangent plus cotangent equals cosecant. So go ahead and give it a try. So the first thing you should have done was to go ahead and rewrite this. So we have cosine theta times 1, I'm sorry, not 1. Tangent in terms of sine and cosine is sine divided by cosine plus cotangent. Remember, cotangent is cosine divided by sine is equal to cosecant. Cosecant, that is the reciprocal of sine, so 1 over sine of theta. Okay. Alrighty, so now what we're going to go ahead and do is we're going to go ahead and distribute this cosine into both terms. So in this case, we have cosine theta times sine theta, right? If we distribute it to the first fraction, divided by cosine theta. I'm going to go ahead and show all my steps, but I know some of you guys can go ahead and distribute much faster than me. And we have something like this, cosine theta over sine theta, okay, is equal to 1 over sine theta. Okay, cool. So let's go ahead and combine like terms. Hopefully you are seeing what I'm seeing. On the first term over here, we have cosine over cosine. That simplifies to 1, and I'm only left with sine theta divided by 1, or sine over 1. And then we have cosine times cosine. That gives me cosine squared theta divided by sine theta equals my right hand side, 1 over sine theta. Okay, cool. Now, this right here intimidates a lot of my students, but what I want you to know is that if this was a fraction, let's say 1 plus 1/4, you would probably tell me, hey, I can change that 1 and I can make it have the same base. So that's ideally what we're going to go ahead and do. We're going to try to find the same base for this, okay? So in order for it to have the same base of sine, I'm going to have to multiply by what that other base is. So I'm going to multiply by sine and sine, okay? This base was sine, so therefore I had to multiply by sine. And I can't just multiply the denominator just like that. I need to multiply the numerator and denominator, because essentially this is the same thing as multiplying by 1, right? 1 is the same thing as sine over sine. Okay. So from here, I have sine squared theta over sine plus cosine squared theta over sine theta is equal to 1 over sine theta. Okay, so the next thing we can do, now that we have the same denominator, think about it like 1/4 plus 2/4. Now we can go ahead and say, oh, that's 3/4. So that's going to be my numerators add together, all divided by the same denominator. Oops, not 4. Oh my goodness. Sine. That's funny. So I have 1 divided by, right? Oops, let me ask you that. Sine squared plus cosine squared. Look at this right here. Which one of these Pythagorean identities does this remind you of? Well, sine squared plus cosine squared is 1, so that's why I'm gonna substitute 1 over sine as my left hand side, and my right hand side, which is right hand side, is gonna be 1 over sine of theta. Sorry about that. So this one is indeed true, right? So this is pretty much helping us in the way of being able to teach us how to prove our identities, okay? Verify our identities, which is what we'll be seeing tomorrow more of. Okay, a little bit of comedy for us. What if for this trig identities, there's, as we get more into it, we'll see that, hey, there's different paths that we can take. There's different methods, and a lot of the times we'll make a little bit of mistakes, but we will always learn from them. So, cool. Alrighty. This is for my students that were with Pear Deck with me live. I'm gonna go ahead and do some of the solutions with you guys. Oops. Okay. So this one right here is pretty straightforward. This one, I believe we should be able to get it. Go ahead and verify that this does work. Okay. All of them will be true, but what I care about is your steps. Okay. This one right here did confuse us, and that's probably my fault because of how I wrote it. I want to go ahead and see what 1 minus cosine squared is. Well, this one right here, I'm going to go ahead and see that, hey, I have squares and I have the number 1. So this one should be hinting you to the Pythagorean identity, okay? Which says cosine squared theta plus sine squared theta is equal to 1. So from here, we're going to go ahead and use our functions to make it match this as best as we can. So we know the 1 is positive, so I'm not going to move that, but the cosine is negative. So I'm going to go ahead and mess with that one right there. So by subtracting it on both sides, I can see that this one will equal 0. So I have sine squared theta is equal to 1 minus cosine squared theta. So now I can see that, hey, this is what I have, which is this right here, is equal to sine squared theta. So that's what I was looking for on this one. Okay. Okay, this one was a little bit tougher, but hopefully not that bad. Let's look at what we do have. We have cosine and sine squared, right? So ideally, what I want you to start thinking is, hey, these Pythagorean identities, this one right here, tells me that all of this cosine plus sine squared, cosine squared plus sine squared is 1. So I have 1 over sine squared theta is equal to 1 over sine squared theta. Making this a step, one more step, we can say that this right here is actually cosecant, right? The reciprocal squared is equal to cosecant squared theta. Awesome. Okay, last but not least, this one really got some of us, but it's not that bad, right? 1 over tangent is the same thing as saying 1 over sine theta over cosine theta, or you could have said, hey, this right here is cotangent. It's up to you, but we're gonna try to simplify. They both give you the same thing. We have cosine theta over sine theta, which is what I did here, plus tangent, which is sine theta over cosine theta, okay, is equal to this right hand side, 1 over sine theta times cosine theta. Awesome, awesome. Now, what I need you to know, guys, is the same thing goes for adding numbers, like adding fractions. If this was 1/2 plus 1/3, we would try our best to make this have the same base by multiplying by 3 on the left hand side and then multiplying by 2 on the right hand side. Whatever it takes to go ahead and make sure that they have the same base. Okay, so we're going to go ahead and try to see the same base. So the same base in this scenario would be sine times cosine. So we're going to go ahead and multiply on the left hand side cosine theta, and on the right hand side times sine theta times sine theta. Keep in mind, guys, this only works if you multiply the numerator and the denominator. So we should have the following: cosine squared theta over cosine theta sine theta plus sine squared theta over cosine theta sine theta. Okay, almost done, guys. Now that we have the same base, just like the example we did before, this is the same thing as saying cosine squared theta plus sine squared theta all over the same denominator, cosine theta sine theta. Okay, so I'm going to go ahead and ask you guys, hey, what property do you see here? Cosine theta plus sine theta. Which one of these Pythagorean identities can help you out? In this case, it would be 1 divided by cosine theta sine theta. Okay, this would be our solution, and indeed it does equal the right hand side and the left hand side. Okay, and tomorrow we'll go ahead and see how we can go ahead and prove this appropriately. Okay, awesome. Thank you for sticking with me up to this minute. And know it is tough stuff, but ideally it is really good stuff that we need to try our best to understand. Okay, as always, guys, it was a pleasure, and thank you. See you on the next video. Bye bye.